Good evening, guys. Same rules as always. Feel free to raise your hand, ask the questions. No problem at all. I'm going to try to make this a quick one. Okay. Um, so we are back talking about understanding OSPF concepts, right? Or what I like to call the fundamentals of OSPF from a CCNA level. I just want to remind everybody. Okay. So in our last session, it's been a while ago, right? We covered a lot of things. We talked about the fundamentals of what a routing protocol is, right? What a routed protocol and a routable protocol is, okay? We talked about that. We talked about, and I'm going to take a pit stop here. We talked about what the main function of a routing protocol is, right? Whenever we were at layer 2 and we were discussing layer 2, we talked about the 3 major functions of a switch, right? Well, routing has 4 major functions, right? So 1, learn routing information about IP subnet from neighboring routers. Whenever you hear about a dynamic routing protocol, OSPF, egrep, you're going to hear, right, words like neighborship, right? Or hellos, something like that, right? To go ahead and discover and create neighborships with one another and different devices, different routers, what have you, okay? So, 2, advertise routing information about IP subnets to neighboring routers. This is one of the main functions that dynamic routing protocols have to do. No matter how they do it, they may be different, but they have to do, okay? 3, if more than one possible route exists to reach one subnet, pick the best route based on a metric, okay? And every routing protocol has its own metric, has its own weight of how it tells which one is the best route to install in the routing information base, AKA the routing table, okay? And last but not least, number 4, if the network topology changes, for example, a link fails, react by advertising that some routes have failed and pick a new, currently best route, right? And what is this process called? Because, of course, it happens in spanning tree as well at layer 2, is convergence, okay? So, with, of course, with a topology change notification, all right? So, let's go ahead, right? We're not going to go all deep and review everything, but assume you guys remember, right? Let's go ahead and talk about some of the concepts of OSPF, okay? So, OSPF, we talked about it. It's a link state protocol, right? And so these link state protocols, they take a little bit of a different approach, right? As far as like the details and particulars of what information they exchange between other routers, right? But when that information is learned from that other router, right, they're going to go ahead and start creating what they call a database, right? But what is used, right? And I keep flipping between layer 2 and layer 3, right? Because I want you guys to understand my method to the madness on why I was harping for you guys to understand a lot of protocols at layer 2. So one of those major functions of routing protocols, right? They have to share that routing information with OSPF. How is that information shared? At layer 2, spanning tree information is shared, right? Information about a switch is shared via a BPDU, right? A bridge protocol data unit, right? So how would OSPF routers share information with one another to go ahead and build a link state database? Using something that they call LSAs, okay? Link state advertising, okay? Right? And so what are those, right? Those are just data structures that have routing information, right? That is the specific data or peculiar data that I was talking about that they're sharing. They're not sharing all the information about the router, but they're sharing that peculiar information as it has to do with OSPF, okay? And so what is it doing, right? It's building the IP, IP routing table. It's looking at, what does this LSA say, all right? Based on the type of LSA, I know what I need to build, how I need to build, and what information this is telling me, right? Okay. It's going to get IP address information. It's going to get the statuses of links, the cost of links. It's going to get the name of the router, something called a router ID. It's going to get all of this, right? Right? So we have a big topology, right? Create a big topology, right? And similar to, again, another reason why I told you guys to pay attention at layer 2. What's going to happen similar at layer 2 whenever BPDUs are just shot out each interface, because of course it's trying to discover, what is OSPF going to do when it's enabled, right? It's going to flood. It's going to flood its broadcast domain, right? Subnet, right? Flood information to all routers. Everybody that's in the same area, everybody that's in the same subnet, right? There's some prerequisites that it has to meet, right? Why? Right? Because it's trying to build out its entire topology. It's trying to change, it's trying to share that information with the entire area. Okay? So, LSAs, they have a very important relationship with creating the link state database. Okay? Well, Dave, why are you telling us that? Well, I'm telling you guys that, right? Is if you're not receiving LSAs, what does that mean? You can't build your link state database, which means you can't build your routing table, which means OSPF within your environment is not operating as a dynamic routing protocol. So something is wrong, something is broken, something needs to be troubleshot. So understanding the fundamentals helps you in a working state, helps you understand how to attack something if it's in a broken state. Okay, so I talked to you guys about flooding, right? You can look at this topology, and this is an example of how that flooding looks, right? So R8, right? We're looking at R8, right? Created this, it's part of this whole OSPF topology, right? So it's flooding, it's flooding its entire topology, this area with LSA, letting it know, hey, this is my network information, right? Here's my link state information. Here's my cost. Here's my router ID. Here's the initial IP address that was used to go ahead and be a part of OSPF. It's going to share a lot of things, right? It's going to share a state and all that, right? This is a visual representation of how LSAs are flooded from an OSPF router, okay? Right? So we talked about flooding, right? It goes ahead and flood those hellos, right? Flood those messages, then it starts flooding LSAs, right? But how do we become neighbors, right? How do we begin to start sharing information, right? Because of course, if I lived across the street from Aaron, right, before we become, neighbors truly, we need to know some information about each other, right? And if you're looking at the screen, I'm sure you guys can read, right? There's a couple of things we need to do before we can truly become neighbors, okay? Right? To where, of course, if I see something going outside his house, right, somebody's breaking in, I can call them or what have you. There are some things that we need to fulfill, okay? So go ahead and read this, right? Becoming neighbors, right? A relationship between two routers that connect to the same data link, okay? Created so that the neighboring routers have a means to exchange their LSDBs. So me and Aaron, we're physically neighbors, right? But we have to create a relationship, right? We have to be in the same neighborhood to be neighbors, right? Okay, let's keep going. Exchanging database, right? The process of sending LSAs to neighbors so that all routers learn the same LSAs. So of course, Aaron is new to the neighborhood. I tell Aaron, hey, Aaron, I know about this, that, these three neighbors over here. Let me share that information. Of course, I know about all these restaurants, right? And here's the information, about my kid or what have you, if you got, just in case of emergency. We're now exchanging information similar to OSPF. We're exchanging a database. Okay. Now, last but not least, and this is where, right, a relationship is truly beginning to grow between two routers, right? Or between two people, right? So me and Aaron became neighbors, right? We have long talks, right, on the porch, right? talking about each other's yard or what have you like that, right? Last but not least, right? How can we be efficient, right? We're sharing best practices with each other. Hey, maybe you should use this for your lawn. Hey, maybe you should use this type of lawnmower, right? Oh, that'll be great, right? Maybe you should do this, maybe you should do that. This is similar to what OSPF is doing with its neighbors, okay? It's going to add the best routes, right? And it's first going to independently run the SPF algorithm, right? The Dijkstra algorithm. It's going to go ahead and do that individually first. It's going to do a local computation, right, of their LSDB, right? And then it's going to go ahead and calculate those best costs, then install it into its routing information base. And I just want to say, right, and I know you guys, most of you guys follow me on social media, and you guys see me studying for eGroup right now. It is the same exact principles, 100%, 100%. Okay, let's keep going. So we're talking about, we're using the example of me and Aaron becoming neighbors, right? But how do we first become neighbors, right? Because if I never go speak to Aaron, I don't never know who Aaron is, right? I need to start by saying hello, right? But one of the prerequisites is that we need to live on the same street, similar to OSPF, right? We need to share the same link, the same physical medium. Okay? All right? So essentially, I need to be a part of the same broadcast domain. Okay? Why? Well, those OSPF messages, right? Those hello messages need to be shot out to the same multicast OSPF group. Okay? They need to be able to hear that. All right? Right? If they can't hear each other, if they're part of the same multicast group, because as soon as you enable OSPF, they're going to assign itself to be a part of that OSPF multicast group, and it's going to be listening for messages on that multicast address. Okay? All right, I'm diving a little bit into CCNP, but that's perfectly fine. I want you guys to understand. Okay? All right? So we're talking, right? And I walk over to Aaron's house and I say, hey, hello, a couple of steps, right? We're in the same area. Hey, Aaron, hello. How are you doing? My name is X, Y, and Z, right? Aaron introduces himself, right? We start to learn about each other. We become neighbors, right? Right? We dynamically became neighbors because, of course, we live on the same street, right? But I'm able to say hello because we're in the same area, right? And that is similar to OSPF, right? You're on the same broadcast domain. You're able to hear those hellos, right? I may do an ARP, do that ARP, trying to find your IP address. I go ahead and start shooting messages, right? I walk through the neighborship process. Boom, here we go, right? But I want you guys to keep in mind, right? Something from this diagram is that for this relationship to begin, we need to go ahead and initiate sending hello packets, right? And how are hello packets sent? As soon as you, one, configure OSPF, and two, enable that interface, right? That's going to share that physical medium with the other router or other routers, right? And you configure, right, that network, right? That network that the interface has to be a network that's a part of the OSPF process, it will now begin to send hellos. Okay? It's going to send that information we were talking about, things about the router ID. Let's go back to that diagram, right? It's going to send a router ID. It's going to send an IP address. It's going to send the state. It's going to send the cost, all in that hello, right? It's trying to hear, right? It's trying to hear and listen for other routers, right? What are the purpose of hellos? Neighbor discovery and recovery. Remember that, okay? Neighbor discovery and recovery, okay? All right. Now, you guys are probably thinking, and we're going to go ahead and go into the lab in a little bit, right? Because I want you guys to actually see it. So what we're going to be looking for, right? And you guys are going to have to know this for the exam. I talked to you guys about the routers joining a multicast address. What is that multicast address? It is 224.0.0.5, right? That is one multicast address for OSPF. Write that down. Keep that in your notes. There is also another multicast address. We will not talk about that just yet. Okay, that's spoilers, right? I'm a Marvel guy, I'm a DC guy, I don't like spoilers. So I just want you guys to remember 224.0.0.5. Okay, that is the multicast address for all OSPF speaking routers. Okay, how does that hello message look like? Right? What we're looking for, and I want you guys to go ahead and keep me honest. What I should see, because it's been a while, what I should see whenever we configure OSPF is that I should see a protocol type of 89 for OSPF, if I'm not mistaken. Okay. All right. Right. And so, like I told you guys, this is similar to how it's going to look in our lab, right? What we should see whenever we're configuring OSPF. Okay. All right. Right. And you guys probably saw different states. Let me go back. You guys see the different states here, right? You see INIT, right? Initializing, right? You see two ways, right? And we're going to talk about that. We're not going to go in depth. I just want to give you guys a spoiler, right, of what that two-way state is, right? And it's an important state within OSPF. And I'm going to go ahead and stop here, right? What's happening at that two-way state, right? When we're sending hellos or what have you amongst each other. Well, one, the router received a hello from the neighbor with that router's own router ID listed as being seen by the neighbor. Let me say it again. One router, router one, received a hello from the neighbor with that router's own router ID, RID, listed as being seen by the neighbor. Okay? What else happened within this two-way state? The router has checked all the parameters in the hello received from the neighbor with no problems. Okay? Right? Remember this example between myself and Aaron. Okay? That router is willing to become an OSPF member, right? And last but not least, if both routers reach a two-way state with each other, this means that both routers meet all the OSPF configuration requirements to become neighbors, right? In which at that point they are neighbors and ready to exchange the LSDB with each other, right? Because they don't initially become neighbors. They don't initially start sharing information, right? They have to get to that state first, right? But we'll stop here, right? In the next section, right? In 2 weeks from now, we'll go ahead and talk about exchanging LSDBs, right? Which we'll talk about the different states of becoming neighbors, okay? So we'll stop here. We're going to the lab. And I want to, of course, show you guys how this looks like, okay? So we have two routers, router 1 and router 2, all right? And we are going to configure, one, a router ID. We're also going to go ahead and configure an IP address on the interface that that are pointing to each other, right? To router 1 and router 2, and of course, where they share that physical medium, right? And then enable that network, right, that they share, okay? So let's go ahead and do R1 first. And unfortunately, within EvenG, I cannot start capturing packets until I go ahead and enable that interface. So let's go ahead and do that first, right? IP address, 6.4.2.1. We're going to make it a /24, keep it easy. All right. Perfect. We should get the syslog messages saying layer 1 and layer 2 is up. Perfect. All right. Save the config. All right. And let's go ahead and we're going to right click and we're going to capture on that interface that we configured our IP address on and we enable. Okay. Right. So as you guys can see, Wireshark is popping up. Okay. All right. I'm going to go ahead and open it up in another browser. Excellent. There we go. All right. So I'm going to have this playing in the background. Right. Okay. Right. And I'm not going to configure router 2 just yet. What we're going to do is configure OSPF here. Right. So I'm going to do router. Right. OSPF question mark process ID. Right. We use process 1. Right. And so first, I'm going to configure our router ID. All right. So we're going to call this 1.1.1.1. Right. You can name it whatever you like. I'm just going to go ahead and stick it 1.1.1.1. Right. Now, I need to go ahead and enable, right, and say, hey, I want OSPF hellos to be shot out of this network, right? And it needs to match up with the subnet that I configured on that interface that is connected to R2. So that's 6.4.2.0, right? But that's not all that I need to do in this command, right? I need to tell it what area, and of course, the subnet in a wildcard, right? In wildcard bits, I need to say those two things before I press enter. So I'm going to go ahead and say O.O.O.255, right? To /24, right? So everything is inverse, right? And of course, last but not least, I need to go ahead and set the area, right? Here's a spoiler. We haven't talked about it yet, right? Every OSPF topology needs to have a connection to the backbone, which is area 0. Okay, so area 0 needs to exist by default. Okay, in this lab, we're going to go ahead and use area 0. Okay, so you guys can see my theory is correct. You can see from a source 6.4.2.1 that we're seeing hello packets being set, right, in milliseconds, right, or seconds, right, to 224.0.0.5. Okay, all right, so we're good, right? Let's go ahead and save this, right? And now let's take a break. Let's go ahead and hop in and let's see what this looks like, right? I told you guys we're looking for protocol type 89. That is correct, right? It's been a while, right? It's been a while, but yes, protocol 89, right? Of course, we see some other information, right? But as you guys see, it doesn't have the LSDB just yet within this packet, right? This is simply just a hello, right? You're gonna have that router ID when you see right here, right? You're gonna have some of the information that you saw in the PowerPoint, right? That's all you're going to see. And of course, it's gonna have all this other information, right? But the core of it is, right? It needs to have the same configuration once they're sharing these hello, and these hellos are detected from one another, right? From these two different routers. Once that's shared, we then build a trust. Now we can go ahead and move on to the next level up, right? So now let's go ahead and configure R2, right? And create our neighborship, right? And see how that process looks. Okay, so let me go ahead and clean this up. And let's do the same thing. Right? Okay, I give it .2, right? And we're going to enable. All right, we should see some syslog messages, layer 1 and layer 2. Perfect, right? And now we're going to go ahead and configure, right? OSPF. Okay, I'm going to give it a router ID 2.2.2.2, right? Network 6.4.2.0, right? Because I want to cover the entire subnet, right? Then I'm going to do those wildcard bits, right? The subnet mask and inverse, right? Then I'm going to go ahead and say what area it is in. Now, when I hit enter, we're going to see the neighborship process happen, right? Those different states. And then we're going to go ahead and be a few things. Of course, you guys can see, like I told you guys, those ARPs are going to happen. Okay. Now we see a different syslog message, right? Adjacency has been completed, right? Right. And we see a few things pop up on Wireshark, right? Let's go ahead and check to see if they're neighbors, right? I like to live by the term trust but verify. Okay. So IP, OSPF. Okay, right? And let's do this. So IP, OSPF, neighboring. Perfect, right? So a couple of things we can confirm here, right? On R1, we have a neighborship with a router that has the router ID of 2.2.2.2, right? Maybe that doesn't tell us anything, right? Maybe Angel says, okay, I know the router ID, but I only know that router by its IP address. Here you go. Okay. So now he can say, I recognize that IP address because I configured it, or I had my network admin go configure that, right? And it's hanging off of gigabit 0/0. So Angel is on the phone with, Aaron saying, hey, this is the interface we set up, correct? Yep, off of gigabit 0/0. Okay. Right? And Aaron is now confirming with Angel, hey, what's your router ID? 1.1.1.1, right? And it's confirming, he's also confirming, hey, your address is 6.4.2.1. Yes, it is. And it's hanging off of gigabit 0/0. You have a neighborship, ladies and gentlemen, right? This is the basics of becoming a neighbor in OSPF at a CCNA level. Okay? With that being said, guys, I will end tonight's session. Please study. Please read Chapter 19 in Volume 1 of the CCNA 200-301 Certification Guide, and I will see you guys next time.
Thanks, David. Bye, guys.